This is the answer to the warm-up question that you were asked to do when you started the Nearopod lesson. So is the graph of p of x equal to 3x times x minus 4 times x plus 5 positive or negative for the interval from 0 to 4? So what you needed to do here was plug a number in from 0 to 4, and it really doesn't matter what number you plug in as long as it's not 0 and as long as it's not 4 and as long as it is between the two. So it does have to be between the two numbers 0 and 4. So 1 would be an easy one for us to use. So we'll do 1, and when we plug that in, we get 3 times 1 times 1 minus 4 times 1 plus 5. Now you could put that whole thing in your calculator at once, or you can simplify it a little bit. It's up to you. So 3 times negative 3 times 6. And we're not graphing this, so we're not necessarily concerned with what the number is. We're only concerned with if the number is positive or negative. And you can tell when you multiply a positive times a positive, you're going to end up with a negative. And if we want to actually know what it is, it's negative 54. So since we ended up with a negative number, that tells us that the graph is negative for the interval. And remember, also remember that what that means is that the graph sits below the x-axis, and it also means that your y values are also all negative for that interval for between 0 and 4. All right, so today is lesson 14, day 4 of graphing factored polynomials. I really kind of wanted to try to make this interactive, but I'm not sure how much I'm going to be able to do that because it is difficult to have you graph in Nearpod. So we'll see how it goes. But the first one here is sketch a graph of f of x equals x times x plus 4 times x minus 2 times x minus 5 by finding the zeros and determining the signs of the functions between the zeros. So remember how we find degree. We look at the x's. We don't have any powers outside the parentheses. So basically we can just count the powers of all the x's, because if you were to multiply x times x times x times x, you would have an x to the 4th. So the degree here is 4. Then the zeros, and let's also mention, remember a degree of 4, because we talked about this previously. A degree of 4 means that both sides go in the same direction. So that means they're either both going up or they're both going down. So our zeros come from taking each of the factors and setting them equal to 0 and solving for x. So we already have the first one, x equals 0. Then we subtract 4 and we get x equals negative 4. We add 2 and we get x equals 2. And we add 5 and we get x equals 5. So our zeros are negative 4, 0, 2, and 5. So we're going to graph those on the x-axis here. So here's 0, here's negative 4, here's 2, and here's 5. Now, as we talked about, you'll see that I put up here a little table for us to just kind of so that we're more organized in trying to figure out the signs of the graph between these intervals. Because remember, and I like to put these little lines to just kind of section the graph off a little bit. You don't have to do this. I put them basically vertical lines through the x-intercepts, just so I know where each section of the graph is. So we're trying to figure out, where does my graph sit in all of these intervals? So what we can do is you can pick a number between each of the intervals to the right of the last x-intercept on the right and to the left of the last x-intercept on the left. So that's what I did here. So I picked a number that was bigger than 5. That would kind of be easy for me to plug in. I picked a number between my x-intercepts of 2 and 5. I picked the number 3. You can see that here in blue. Then I picked a number between 0 and 2. I used 1. You can see that in blue. And a number between -4 and 0. I picked -1. And then a number to the left of -4. I picked -10. So we plug all those numbers in. And again, I mean, really, you could be using a calculator to do this pretty quickly for plugging the numbers in. So let's start with f of -10. So when I plug -10 in, I have -10 times -10 plus 4 times -10 minus 2 times -10 minus 5. And then again, you could type that into your calculator all at once, or you could just figure out what they are. When we plug them in, we get -10 times -6 times -12 times -15. So again, we're not necessarily concerned with what the values are. If we want a somewhat of an accurate sketch, we would kind of figure those out. But just knowing whether the number is positive or negative is all we really need here. So if I take a negative times a negative times a negative times a negative, I'm going to get a positive. So I'm going to put a plus here. So what that tells me, and I'm going to put equals positive. What that tells me is that the left side of the graph is sitting above the x-axis. That's what it tells me. So that means, let's do this. I can draw the left side of my graph so that's sitting above the x-axis. Then when we look at -4 to 0, this interval right here, we pick a number and we plug it in. So I'm plugging in -1. So when we do f of -1, what we have is -1 times -1 plus 4 times -1 minus 2 times -1 minus 5. So again, I'm checking to see, does that give me a positive or a negative result? So if you simplify it a little bit, it's probably easier to see. -1 times 3 times -3 times -6. I have a negative times a positive times a negative times a negative. So that is going to be negative. So that tells me that between -4 and 0, all of my points are going to be below the x-axis. They're all going to be negative. So my graph is going to come down like this. And again, these aren't truly accurate y values, because if you actually multiplied -1 times 3 times -3 times -6, you would get -54. I'm not going down that far. I mean, I can make it go down further, but it's still not going to go down far enough for -54. Then it's going to come back up to this x-intercept, and it's either going to turn around and go back down, or it's going to go straight through. So that's why you have to figure out what's happening in the interval from 0 to 2. So you're going to plug the 1 in. Now I'm running out of room, so we're going to have to bring in a new slide. So when we plug 1 in, what we get is 1 times x plus 1 plus 4, sorry about that, and 1 minus 2, and 1 minus 5. Let's make sure I have the right, yes. So what I get is 1 times 5 times -1 times -4. So a positive times a positive times 2 negatives is going to be positive. So I know in that interval it's going to be positive. So I know the graph is coming up here, and it's going to turn around and come back down to this x-intercept, and it's either going to keep going or it's going to bounce off and go back up. So we need to plug in the 3 from the interval from 2 to 5. Again, you could do the 3, you could do the 4. I don't think you want to do any decimals, but that's up to you. So we're going to plug in 3. So it'll be f of 3 is equal to 3 times 3 plus 4 times 3 minus 2 times 3 minus 5. So we have a positive times a positive times a positive times a negative, which will be negative. So that means it's coming down here, turning around and going back to that next x-intercept of 5. And we have to see, and actually, guys, if you go back to what our degree is, we said that both sides of the graph are going in the same direction. So if the left side is going up, you know the right side is going up too. So you really wouldn't even have to plug in 10, but if you wanted to, you could. And what we find is that it will end up with a positive value, so it's going to go up. So that's a rough sketch of your graph. Notice I don't have the y-axis labeled at all because none of these points, I didn't want to have it labeled because I didn't want to go to -54 on a coordinate plane like that one that we had talked about. So sometimes the values can get really big. So it's best not to have any numbers on your y-axis when you're just trying to sketch the graph. All right, let's keep moving on. Sketch a graph of f of x equals -x cubed minus 6x squared plus 9x by finding the zeros and determining the signs of the functions between the zeros. Well, this is in standard form, so we know what the degree is. It's degree 3. Please be careful. You're not supposed to add all of these together. This is in standard form. We only do that when it's in factored form. That's where we have to look at all of the powers of the variables. Now, this is a little bit harder to determine what the zeros are because it's not in a factored form, so you're going to need to factor it. So notice we have a GCF of -x. So you're going to pull that out and multiply it by what you would have left, which would be x squared minus 6x minus 9. Oh, I'm sorry, that should have been plus 6x. Sorry about that. All right, so then factor that x squared plus 6x minus 9, and it factors into factor pairs of -9 that add to give you a -6. So when we start thinking about that, it's not factorable. Okay, there aren't any factor pairs of -9 that add to give me a positive 6. So what do I do in that case? Well, here's what you'd end up having to do. This is not factorable. So it doesn't mean that we don't have any solutions. It just means that our solutions are going to be decimals. So we have a solution from the x that we put in the front. That's going to be 0. So we have that one. But to get the solutions for x squared plus 6x minus 9, you're going to have to use the quadratic formula. Or you could do completing the square if you wanted to. Could really do either one. So we just got done doing the quadratic formula. I really don't want to spend a lot of time on that. I'll set it up for you, but basically what you end up with is x is equal to -6 plus or minus the square root of 72 over 2. Now, on our tests, I said you got to simplify your radical if possible, no decimal answers, but because we are graphing, we have to figure out the decimal answers because none of us know where -6 plus the square root of 72 divided by 2 is on the coordinate plane. None of us know where that is. So we need to figure out what those decimals would be. And actually, this should be a plus the square root of 72, and then a -6 minus the square root of 72 divided by 2. Now again, you're going to have to put that into a calculator, and when you do, the entire top should be in parentheses for both of them. And again, you should check this on your own calculator. What you get is 1.2 and -7.2. All right, so those are answers for the decimals. Now we have all of our zeros, -7.2, 0, and approximately 1.2. So we're going to go to the next slide and we're going to graph those. So my -7.2 Would be good if I had enough room on here, but I do not. Sorry about that, guys. So negative 7.2 is going to be right about here. So that's not a really good placement for our, let me do this real quick. Let's try this. Give me 1 second. Our graph is not as good as it should be here. I'm going to snip it and slide it over a little bit. That way we can have some room here. All right, so what we'll do is we're gonna make this work. Oops, maybe. All right, so what I'm gonna do is I'm going to make we're gonna try and get this to work. Give me a second. All right, so here's going to be our negative 7, and then negative 7.2 is going to be right about there. So that will be one of our x-intercepts. So I'm going to put my red dashed line down through here, and then we'll have another one at 0, and we'll have another one at 2. All right, so there they are. So now we have to pick numbers that fall in our intervals and to the right and left of our furthest x-intercept to the right and our furthest x-intercept to the left. So what I did, oops, 1.2 should be right here. Boy, my brain doesn't want to work lately. There we go. 1.2 should be right about there. All right, so I picked a point to the right of 1.2, which is the 2. So I did 2, and I have that in blue in our chart over here. Then between 0 and 1.2, I picked 1. And then between 0 and negative 7.2, I picked negative 3. So again, all we're worried about is what is the sign. Now, we also said our degree was 3 back in the beginning. So remember what we know about an odd degree. So the sides go in opposite directions. So that's helpful with this. So this time let's plug in the 2. So let's plug in 2. So we're going to do f of 2 first. And when we plug 2 in, we get negative. Now this is where you have to be really careful, guys, okay? Because there's a negative in front of the x cubed. Some people like to write that as a negative 1. And that's really helpful sometimes because you want it to be separate from the x. So negative 1 times 2 to the third minus 6 times 2 squared plus 9 times 2. So again, we're more concerned with, is this going to be positive or negative? And when we figure it out, it ends up being negative. And again, you can type it into a calculator, which for some of you that might be easier here to figure it out. But what we end up with is negative 14. Again, we're not really concerned about the number. What we're concerned about is the sign. So it's negative on that interval. So we know that to the right of 1.2, the graph is pointing down. So I'm going to draw it from that x-intercept of 1.2 pointing down. Then when we plug 1 in, we get negative 1 times 1 to the third minus 6 times 1 squared plus 9 times 1. So when you plug 1 in, it's going to be positive 2. So you know when the graph hits this x-intercept, it's going to keep going through instead of bouncing back down. So it goes straight through here, comes up. I'll draw that a little better. And it turns back around, comes down to this x-intercept at 0. Okay, we have an x-intercept at 0. And then we'll check between So let me put that in there. So then what we need to check is between 0 and negative 7.2. What does the graph do? So does the graph bounce off the x-axis and stay positive, or does it go straight through that x-intercept and sit below the x-axis? So that's why you're going to plug in -3 to figure it out. So when we plug in -3, let me go back to my purple here. When we plug in -3, now this is where it gets tricky because there's already a negative in front of the x cubed. So keep it -1 times -3 to the third minus 6 times -3 squared plus 9 times -3. So when we figure that out, we get -54, which is negative. So that tells us the graph goes through the x-axis, comes down, turns around, goes back to this x-intercept of -7.2. Then we need to decide, what does it do at that point? Does it bounce off the x-axis and go back down, or does it go straight through? So knowing what we talked about with degree, the sides go in opposite directions, right? Because it's an odd degree. So since this side of the graph is pointing down, we know this side is going to be pointing up. So you don't have to plug in another number after -7.2 to figure out what's happening on that side, because they have to go in opposite directions since the degree is odd. All right, so just to clarify, guys, notation-wise, this is the interval for x greater than 1.2. This is the interval for x less than 0 but greater than 7.2. And this interval here is the interval x less than -7.2. So those are the different intervals for the graph. All right, let's keep going. So obviously we're not doing breakout rooms. So let's talk about this one. Sketch a graph of f of x equals -x times x quantity x plus 3 times quantity x minus 2 by finding the zeros and determining the signs of the functions between the zeros. So here's where you're going to look at the degree. Since we have no powers, we just look at the x's. If we were to multiply all three of those, it would be an x to the third. So our degree is 3. So graph goes in opposite directions on the sides. So what are my zeros? So take each part by the zero product property, set it equal to 0, and solve for x. So we do kind of like it when it's in factored form because we don't have to do a whole lot to figure out the zeros. So -x equal to 0, if I divide both sides by -1, I get x equals 0. Subtract 3, I get x equals -3. Add 2, and I get x equals 2. So those are my zeros, -3, 0, and 2. All right, we go and we graph them. So how do I set up my little table here? Well, my x-intercepts, let's graph them in red. My x-intercepts are 0, -3, and +2. So I'm going to put those x-intercepts above my lines here in order. So -3, 0, and 2. And then what I'm going to do is I am going to pick numbers in those intervals that I can plug in to see what my graph looks like. So for the interval of x less than -3, I'm going to pick the number -4, and I'm just going to put it above the box. And then for the interval from 0 to -3, I'm going to pick, let's do -1. And then from the interval from 0 to 2, I'm going to pick 1. And then for the interval of x greater than 2, I'm going to pick 3. Now, since we know the graph's supposed to go in opposite directions, you really don't need to plug in both the -4 and the 3. You can pick which one you want to do, and then you know what the opposite side is going to do. So I'm going to do a 3 because usually plugging in positive numbers is easier for a lot of us. So if we do f of 3, again, that x in the beginning is negative. I would put a -1 to represent that negative in front of the x. So -1 times 3 times 3 plus 3 times 3 minus 2. So what we get is -3 times 6 times 1. That's going to be negative. Now it's going to be -18. Again, we're not really concerned about the numbers right now. We just want to know what's happening with the graph. So since it's negative, you're going to, oops, wrong spot, guys. Let me put it over here. Since it's negative, you know that the right side of the graph sits below the x-axis. So it's down here. The right side is going down from that x-intercept. That tells you that on the left side, the graph is going to be going in the opposite direction, so that at this x-intercept of -3, you know the graph's going to go up because they have to go in opposite directions. So you don't even have to plug in the -4 unless you want to. Let's plug in our other two values. Let's do the -1 next. So I get -1 times -1 times -1 plus 3 times -1 minus 2. So that gives me 1 times 2 times -3. And that also is going to be a negative. 2 positives times a negative will be negative, and it'll be -6. So my graph for this interval is negative. So when the graph comes down here to this x-intercept, it goes straight through because it's going to sit below the x-axis in that interval. Then it's going to come back up to that x-intercept at 0, and it's either going to go straight through or it's going to bounce off the axis and go back down. So we plug in f of 1, and I'm going to sneak that in over here. We get -1 times 1 times 1 plus 3 times 1 minus 2. So that gives us -1 times 4 times -1. And two negatives give us a positive. So it's going to be positive. So in that interval, the graph is going to go through the x-intercept of 0, go up, and come back down to that x-intercept at 2. So that's a rough sketch of our graph. All right. Let's see. I think we have a couple more here maybe to do. All right, so let's take a look at this. So the Khan Academy assignment that you're going to be doing on Monday has to do with positive and negative intervals like we just talked about. So it says f of x equals the quantity 2x plus 5 times x plus 3 times 3z minus 10 times 2x minus 8. Tells you what the zeros are for all of these. So you don't even have to solve those to figure out the zeros. They tell you the zeros are -3, -5/2, and over 3, and 4. They want to know what is the sign of f on the interval -5/2 less than x less than 4. So now here's what I would suggest that you do. I would suggest that you do a rough sketch of a number line and you put these points on there. So -5/2 is -2.5, and 10/3 is approximately 3.3, repeating. So we'll know where those go. So -3 is the smallest one, then -2.5, then 3.3, and then 4. So those are all of your x-intercepts. Now, they ask you what is going on, what is the sign of f on the interval from -5/2 to 4. So they want to know what is the sign between these two x-intercepts. Now, if you notice, you actually have two intervals in here because you have the interval here, you have this interval at -2.5, and you have this interval at 4. So the thing with this that you have to be careful of is they want to know over 2 intervals what the signs are going to be. Are they always positive? Are they always negative? Or sometimes positive and sometimes negative? So what you're really going to have to do to figure this out is plug a number from this interval into the equation and plug a number from this interval into the equation. Now for this one, 0 is in that interval. So plugging 0 in is, makes things pretty easy. So one of your interval points, I would use 0. Okay, so let's plug 0 in and see what we get. So f of 0 is equal to 2 times 0 plus 5, 0 plus 3, 3 times 0 minus 10, and 2 times 0 minus 8. So when you look at all of that, right, so here's what we get. 5 times 3 times negative 10 times negative 8. So if you notice, positive times a positive times a negative is going to be positive. So the graph in this interval is going to be positive. So it's going to go up like this. It's going to do something like that. Now it's either going to, at this one, it's either going to bounce off and go back up, or it's going to go straight through. So between 3.3 and 4, you're going to have to do a decimal. But the great thing is you have a calculator, so you can always use your calculator. So I would do 3.5. That's probably what I would do here. So let's do 3.5. And I'm going to go up to the top of the screen because I'm running out of room. So when we plug 3.5 in, 2 times 3.5 plus 5, and 3.5 plus 3, and 3 times 3.5 minus 10. Oh, we're really running out of room here. Hang on, guys. Let me move this over. And then 2 times 3.5 minus 8. Okay, so in looking at this, again, you might be able to tell if it's going to be positive or negative. You might have to get a calculator out. I actually don't have this done on my calculator yet, so let me plug it in there. So for the first one, you know it's going to be positive because you're taking 2 times 3.5 and you're adding 5, which is 12. And then 3.5 plus 3 is 6.5, so that's also positive. Then 3 times 3.5 minus 10. If you're not sure if that's going to be positive or negative, I would do it on a calculator. And what you get is that it is positive, 0.5. And then the last one, 2 times 3.5 minus 8. So again, if you're not sure if it's going to be positive or negative, then check it on a calculator and you get a negative 1. So this is going to be negative because a positive times a positive times a positive is going to be a negative. So it's going to go down here, turn around, and come back up through that x-intercept. So it's negative in this interval, but positive in the other. So your answer here is C. F is sometimes positive and sometimes negative on the interval. So just watch for that. Sometimes they'll ask you over 2 intervals. Sometimes they'll ask you over just 1. All right. Last thing for today is actually pretty easy, and I think that, we can bring in some, maybe some interaction on these, but this is relative maximum and minimum. So these are your hills and valleys, basically, guys. So every graph, not every graph, straight line graphs do not, but anything other than a linear equation has curves, okay? So it has curves, and with those curves, you get hills and valleys. So the top of a valley, the top of a mountain or a hill is called the relative maxima or maximum. And then the bottom of a valley is called the relative minimum. So these are always ordered pairs. And what we need to remember is that the y value of the ordered pair is the actual maximum and minimum. The x value of the ordered pairs tells you where it occurs. So we'll take a look on a couple of slides here, but like I said, the y value, because that's the height, right? So the y value is the actual maximum or minimum, and then the x value of the pairs tells you where it occurs. So let's take a look. So just in explaining relative max and min a little bit. So the tops of the mountains are called the relative maximums. Okay, so this is a relative maximum and this is a relative maximum. So what you want to think about, even though this one is smaller than this one, they're still both considered relative maximums because they are the highest points in their little neighborhoods, is how you want to look at it. And then these 2 points would both be considered relative minimums because they are the bottoms of the valleys. So even though the one is lower than the other, they're still both considered relative mins. So you have your relative max, you have a relative max, and then you have a relative min and a relative min. So if you know what maximum means and you know what minimum means, that really does help you remember, what these are all about. So let's take a look at naming them. So if you think about it, here's another way to look at it. So at the top of there in that paragraph, if you're in a room full of people and you find the tallest person there, a lot of times it is a guy, he would be the relative max for that room. He's the tallest relative to the people around him. But if you took that same person to an NBA convention, like it says, there would be a lot of people who are taller than him, right? So relative maximum just pertains to that little section of the graph that you're looking at. All right, so let's talk about these two relative maximums here. So this is what I was talking about in naming them. Just try to remember that the max and the min refers to the height. So the y coordinate of this ordered pair is 2. So we say that there's a relative maximum of 2 at an x value of -3. And then for this one, it's the same thing. The height of this mountain is 1 if compared to the x-axis. So it has this relative maximum. This function has a relative maximum of 1 at x equals 2. So again, guys, the max is always the height. The x is where the max occurs. So the x coordinate of the ordered pair is where the max occurs. The y coordinate is the actual maximum. And same thing with minimum. All right, so let's take a look at this one. So relative mins here. So we have a relative min at -3 or of -3 at x equals -1. Then we have a relative min of -1 at an x value of 4. Okay, so remember, height. Height is always the y coordinate, and that's always the max or min. All right, so what I'm going to have you do is take a look at this one and see if you can identify all the relative maximums and minimums. And that's going to be definitely an interactive part of Nearpod, and so you'll answer that when you're working it out. And I'm going to talk about them now. Let's talk about the relative maxes first. So we have one here, here, and here. So this is an ordered pair of 1, 2, 3, 4, 5, -5, +1. This one is at 0, 3, and this one is at 4, 1. So here's how we would name them. So we have a relative max of 1 at x equals -5. And we have a relative max of 3 at x equals 0, and we have a relative max of 1 at x equals 4. Let's talk about the relative min. So that would be these two. This point is -3, -2, and this point is 2, 0. So we have a relative min of -2 at x equals -3, and we have a relative min of 0 at x equals 2. So again, guys, the y coordinates are the max or min because they're the heights. And then the x coordinates are where those max and mins are occurring. Then down there in the bottom in yellow, it says a polynomial of degree n can have at most n minus 1 relative extrema. So you might be saying, well, what is relative extrema? Well, that's the two of them together. So that's all it's referring to. So a polynomial of degree n can have at most n minus 1 relative extrema. So if the degree is 6, all this is saying is that at most you're going to have 5 relative max and min all together. If the degree is 4, you're going to have at most 3 max and min. Okay, so total. So if we go back and look at a couple of our graphs real quick, let's see back here. Okay, so we said this was degree 3, so we would have at most 2 relative max and min, and you can see we actually have 2. We would have one here, a max here, and a min here. If you go back to, I wanted to do the one that was 4, this one. So this was degree 4, so we have at most 3, it's always one less, so we have at most 3 relative max and min. And if you look, we have 2 relative min and 1 max. So we have at most 3. All right, guys, so this was a little longer than normal when I do something like this, but it's a lot of important information. I hope you took a lot of good notes. And you're going to answer a question near pod on explaining what a relative max and relative min is in your own words. The homework is lesson 14, questions 5 through 6, 8, 15 to 16. The assignment for Monday, because I'm still out on Monday, will be to do the Khan Academy assignment, lesson 14, positive and negative intervals. All right, guys, that's it. Have a wonderful day.